Okay, welcome to part 2. We are going to move on in this part to starting with using chlorine dioxide. Now, this method, using chlorine dioxide, uses neither hypochlorous acid nor chloramines in the process. It kills protozoans, Cryptosporidium, Giardia. It oxidizes all metals and organic matter, which means it produces no trihalomethanes. It also removes sulfide compounds and phenolic taste and odor. And it's effective at higher pHs than other forms. Sounds too good to be true, huh? Well, the bad news is that it must be generated on site. It's costly. It takes a higher level of skill to use and operate, and it is highly combustible. Okay. Well, this looks like a repeat of a slide we've already had, but I'm going to go over it anyway again. This is the slide where I talked about the chlorine residual in the clear well should be 0.5 milligrams per liter. The chlorine residual at the extreme end of a distribution system should be 0.2 milligrams per liter. And when we do the sampling lecture, we'll talk a little bit more about sampling in the distribution system. And again, a reminder that chlorine dose plus equals demand plus residual. And that residual is called free chlorine residual. And the combined chlorine residual is the same thing as chloramines. They are a weaker disinfectant, they need longer contact time, and they have higher chlorine than free residual chlorine. Forgive me, I don't know exactly what, I think that might be a typo. Anyway, it's fine. They do need longer chlorine contact time. In a small system, typically test 3 times a day and every 2 hours in larger systems. Now, the CT value is the measurement of the degree of pathogen inactivation from chlorine. It's the moment when chlorine is added to the water to when the it's used. And the minimum time is 30 minutes. So your CT value is the residual times the contact time in minutes. So they are in inverse proportion to each other. You increase one, you decrease the other. Just for information, viruses, Giardia, and Crypto need residuals of 1.2 to 2 milligrams per liter and longer contact times to be effective. And here's a review of the chlorine residual test methods. We've already looked at these. What I'll just call the OTO method is an obsolete test method used until the 70s. It was carcinogenic, so it's gone. The other is the DPD. It's the approved method for field testing. And I have a note in there about watching the basic operator DVD. And I've spoken to 1 or 2 of you individually about this. And this is a DVD that comes from the Montana Water Center. And it's an excellent DVD. It's got some excellent teaching, some good math review. I recommend you going to the site and downloading it or ordering the CD. It's free. It's just a good review. It's good reinforcement of everything that you're already getting in the course. We unfortunately took out a lot of the parts of this DVD because it wasn't easily accessible by students who had sight problems or hearing challenged. So that was why we didn't use it, but I do recommend it. And if you want more information, you know what I'll do? I'll just put a general post up on the information learning community forum. And then the last test is the amperometric titration. It's a lab test. It's not done in the field. Okay, moving on to chlorine cylinders and chlorination methods, and then we're going to talk a little bit about safety as well. So chlorine cylinders come in 150-pound and 1-ton sizes. Psst, it's on the quiz. Also can come in 100-pound and 55 to 90-ton rail cars, which probably will not be in your experience. The chlorine is condensed into liquid form, but it expands as the gas leaves the tank. The liquid to gas change takes heat from the surrounding air and can cause the tank to frost up. No more than 350 pounds per day rate for a 100 to 150 pound cylinder to prevent frost. You need to use a manifold if needed. In other words, several different outlets in one manifold. To get your accurate feed rates, you need to weigh the cylinder and then minus out the tare weight, or the weight of the cylinder itself. And for safety and just to prevent accidents, the cylinder should be chained to wall or scales unless they're being moved. A vacuum chlorinator is also called a solution feeder. Again, I mentioned the Operator Basics DVD. It's got some great stuff in there about the chlorinators. And our textbook also does as well. So the way that it works is that the gas is pulled into the water by a vacuum. This vacuum can be controlled manually or with a controller, i.e. it can be made flow proportional. It is considered safe since any line breaks would break the vacuum and close the valve, the pressure reducing valve. And this gas chlorination is used by systems that require large doses of chlorine. So think about the American Canyon site, or in wastewater, think of the Laguna treatment plant. There's also direct feed. The gas is under pressure and it's pumped directly into the main flow. Then it is dispersed into the water by a diffuser. No pressurized water supply is needed. However, it is prone to leakage, so they tend to be used for small systems or emergency. And here is a great image of what you would find on the that DVD. Explains the process. Okay, so hypochlorination systems, in other words, using liquid or solid dissolved chlorine. The simplest method of continuous chlorination for system flows less than 75 gallons per minute. The pump is motor driven and it pulls solution out of a holding tank and it pumps it into the water. You can adjust the chlorine feed in 3 ways. You can vary the pump pulley size to adjust the stroke length or machine speed, or you can change the hypochlorite solution strength. These have lower equipment costs, therefore hypochlorination tends to be better for smaller systems. Okay, so we are already looking at some of the aspects of chlorine physical symptoms when you've been hit by a cloud of chlorine or a high concentration of chlorine. There would be a noticeable odor at less than 0.2 parts per million. The irritation after several hours would, in your throat, and at 1 ppm, 1 part per million. Throat irritation after several minutes at 5 ppm. Immediate coughing at 30 parts per million. Dangerous after 30 minutes. this would be at 50 parts per million, and lethal to humans in minutes, 1,000 parts per million. So for handling HTH chlorine, you just want to keep it in a cool, dry place. This is solid chlorine. You want to make sure you have respiratory protection, gas or canister masks with a filtering device, self-contained breathing apparatus, SCBA, full face mask, and damage caused by exposure is cumulative with future problems. Use water to wash chlorine from body and equipment. Now this is just a general chlorine safety. We have a whole lesson on safety and emergency response later in the class. So just an overview, just a small amount. Now, just going to talk a little bit about masks. They are, with a filtering device, they are intended for escape purposes only, not for entering to deal with a leak. And it won't work if oxygen concentration drops below 12%. So you just want to, this is just to get yourself out of a chlorinator room or a place where chlorine has accumulated, just to get out. It's not meant to be, to work with, to, keep it on and work on a problem. That would be a self-contained breathing apparatus, or SCBA. Must be used when working in chlorine gas atmosphere. And the mask is connected to an air tank that lasts 30 minutes. And the tank has a low air alarm, similar to a scuba diving tank, if you've ever done that. And both masks and both types of masks need hair and beard clearance for a proper fit. So just some food for thought for those of you sporting beards and longer hair. That could be an issue for your mask working properly if you're in that situation. So the next slide, we're going to talk about a chlorinator room. These are some of the necessary things for a chlorinator room. There should be a window in the door. The light and vent switches should be outside, and you always want to ventilate the room before you enter. And the ventilation should be at 12 inches above floor level. And if you think about that for a minute, the reason why they're lower is because chlorine gas is heavy, and so you want that ventilation to, the gas to get to the ventilation at a lower level. At 60 to 120 degrees Fahrenheit, it's too cold for the room. Green ice or chlorine hydrate forms, clogging injectors in the gas piping. When it's too hot, the gas can expand. At room temperature, gas is 85% in volume in the tank. And always ventilate the room before entering. Already said that. And this is a little bit of a repeat. Cylinders and drums of dry chlorine should be kept dry and well ventilated. A separate room with only chlorine. Separate your full cylinders from your empty ones. Chain your unused cylinders, gas cylinders I'm talking about, to the wall. Keep your HTH separate. No contact with petroleum or organic solvents. Otherwise, you could have an explosion. Boom. And emergency response procedures. So there are 4 components of an emergency response plan. You want to be able to contain and repair the leak, notify other emergency preparedness agencies, evacuation plans for the general public, and medical evac for casualties. This is really the very skim of a plan. We are going to do a lot more in the emergency response lesson, in the safety lesson. Okay.